Oh yes, let's continue. Now, in the book, we have some examples with point coordinates that you can look at them. We're gonna go for directions. Now, directions are this expressing the set of atoms that arrange on a line. We're going to use direction to express the arrangement of atom in a line. Now, what does that mean? If you remember, let's come back to the atom arrangement that we have them. Now, coordinate, we said that it's the location of each atom. So what will be the direction? Direction is representing a line of atom. Direction represent a line of atom. Now let's say I'm taking this is, we call the direction of atoms. For example, 1, 2, 3, 4 atoms, their direction, this is we call the direction. Or for example here, if I'm choosing different color. Now, if you look at this, we call this one a direction. Now look at them. A direction means that set of atoms, basically, they lies on one line. We call them direction of atoms. For example, this could be a direction of atoms. I mean, we have a lot of direction, yes? Any way that you're looking at it, we have direction. I mean, this is a direction, we can call it like this. I mean, this will be a direction. So look at this direction here. It's different than the direction here, will be different than this direction, different than this direction. So each direction, even we have a space direction here, but I'm not sure if it will be clear from here. For example, we can go from somewhere here, goes to that corner. If there is some atoms touching each other, we will call those, or each of them, direction. So point coordinates, we talk about them as the location of each atom. Direction will be representing as a vector. So direction is a vector. So vector, which we know that has a magnitude and direction. In mathematics, we know that. Magnitude here will be the length. Magnitude will be the length. Direction will be the head. Is it facing this direction or the other way? I mean, it doesn't matter. But we have to know also the direction of the sense of the direction. The sense, we call the arrow, wherever it's heading of the direction. So in order to be able to deal with directions, we have to know point coordinates. So if you have to watch the point coordinate video to understand how to find those coordinates, then it will be easy to deal with directions. Again, when we're dealing with direction, we have two methods. One, to find the direction. I mean, if you have a set of atoms, you want to find the direction. The other one will be drawing the direction. So we're going to talk about both of them. Again, the way that we said that in point, we have the point coordinate, we had two ways. In the direction also, we have two ways. So the first one, we're going to talk about it. Let's say we're finding the direction. Now let me draw some directions. And we're going to find them. We're going to find each of those directions to see how would you represent directions. Yes, I haven't talked about it, so we're going to talk about them later. Now let's say I have a direction like this. This is a direction, yes. Let's start with the easy one. Let's start with a very easy, simple one. This is a direction. I mean, from here I can connect to this one. This is a direction. Now those are direction, we call them. Direction. Don't want to make it crowded. We may have different pictures. Now, let's say we want to find how do we represent this direction. For example, the first one, we have two directions, 1 and 2. We have two directions, 1 and 2. How do you represent those directions? Well, I'm not talking about the atoms yet. Not talking about the atoms. Just I want to represent this direction. So I have direction 1 and 2. Direction 1 and 2. Now, in order to represent direction, we're going to use this manner, a bracket, a square bracket we call it, nicely, a square bracket, closing bracket. Now inside here we don't have x, y, z. We don't have x, y, z. Why? Because we have direction. We have three different terms that we use them, indices, h, k, l. h, k, l. We have three indices, h, k, l. In the book there's something called u, v, w. Some even they call x dash, y dash, z dash. The book that we're having it, they call HKL. Indices, three number. Now, how do you find HKL for each of these vectors? I'm writing the general equation for H. Basically, H will be x2 minus x1. Let's make it more general. Let's type it. H is equal to x for the head minus x for the tail. Now, head and tail, we're talking about vector. We have arrow, which is the head, and tail would be here. For example, this is the head, this is arrow. Sorry, this is the head, and this is the tail. Now, it means that in order to find a direction HKL, I need to have the two coordinates, the tail coordinates and the head coordinate. So I need to find this coordinate here. I need to find this coordinate here. Then for this one, I have to find the first coordinate and the second coordinates. Now if I have the coordinates, then I'll be going to use it to find HKL. So this is H, and you know that the rest will be K, HK. K will be Y head minus Y tail. Then L is going to be Z, will be Z of the head minus Z of the tail. So if you know how to find the coordinates, of each of these 2 points, then you'll be able to find the HKL, which will represent this direction. Now, the easiest way to find direction, HKL, it is to assume origin at the tail. Origin here, it's up to you. For direction origin, you can, to find any direction, move the origin to the tail. So what does that mean? So we're trying to find for this one. Let's say this is A, direction A, this is direction B. Now we want to find for direction A. For direction A, this is the tail and this is the head. Yes, this is the head. Now what we're going to do, we're going to assume our coordinate system somewhere at the tail. We'll decide this is the origin. So this is X, make them small. This is X, this is Y, this is Z. Now if you do this process, what does it mean? It means that always tail will be 0, 0, 0. Yes, the tail will be 0, 0, 0. Why? Because I will put the origin at the tail. Look, if I want to do it for B, I'll put the origin at tail. This will be the origin. We're going to change it because each direction alone, so you don't need to use this origin to find B. We're going to show it to you, it's still the same. It's still going to be exactly the same. So let's say we're going to use this origin here to find both of them. Then I'm going to tell you how easily, if we move this here, we can easily find B by shifting the origin from here to this point. Now let's talk for point A. Now tail is 0, 0, 0. Now the coordinate of tail is 0, 0, 0. This is the coordinate of the tail. The coordinate of T will be 0, 1, 0. So this is X direction, remember. This is Y direction, and this is Z direction here. So point 2 will be 0 in X, 1 in Y, 0 in Z. Now, if I want to find this direction, well, for edge, X for the head, which is here 0, minus X for the tail, which is 0, 0 minus 0 became, so for A, square bracket, H became 0. For K, will be Y for the head, this is Y for the head, which is 1, 1 minus 0, 1 minus 0 is 1. Then for the L, Z of the head, which is 0, Z of the head is 0, minus Z of the tail, again will be 0. Now the direction AA became 0, 1, 0. 0, 1, 0. Let's talk about direction B. Direction B. Now, let me find the coordinate of both points. Coordinate of this point and this point. That's a coordinate of point 3, point 4. This is the tail. Coordinate of 3 will be 1 in X, 1 in Y, 0 in Z. 1 in X, 1 in Y, 0 in Z. Coordinate of point 4 will be 1 in X, 0 in Y, 1 in Z. 1 in X, 0 in Y, 1 in Z. Now, this is the head, so it will be head minus tail. For B, we're going to find H, X of head, 1, 1, minus 1, 1, minus 1, 0, 1, minus 1, 0, 0, minus 1, the Y this time, 0, minus 1 will be minus 1. We're going to write minus 1 in this manner. We're going to put a slash over it. This is minus 1. Then for Z will be 1 minus 0. 1 minus 0 is 1. So this is the direction B. 0, minus 1, 1. Just simply, this is the head and this is the tail. Head minus tail. As you see, head minus tail. X of the head minus X of the tail, and so on. You're going to have the direction. Now imagine if I move the origin, let's say I have a new origin. It's up to me, yes. I can decide the origin to be at this point here. Now let's say we're deciding origin to be at this point here. What will happen in that case? I'm just trying to find B. Well, the coordinate of this point here no longer will be this point. Will be what? Will be 0, 0, 0. So I'm going to use a new coordinate. For the tail will be 0, 0, 0. We're going to find this coordinate here for B. Now this is Y positive. This is Y positive. This is X positive. Now we have to go in this direction. This is in the negative Y. Negative Y. And then to here, the new coordinate will be 0, minus 1, 1. Now, if you find the coordinate direction now, because all of them 0, directly this will be the direction. Directly I will write this one as a direction. 0, minus 1, 1. Why? Because if you place the origin at the tail, the coordinate of the head will directly be the direction. The coordinate of the head will be the direction directly. Look at here, 0, 1, 0 directly became 0, 1, 0. Why? Because the origin was at the tail. Here, if you bring the origin at the tail will be 0, 0, 0. Find the coordinate of the head, thus directly will be the direction. Or leave the origin any way you want, doesn't matter. I prove it for you. If the origin was here, we still find this one. I brought the origin here, we still find the same thing. Why? Because 0 minus 0 minus 0 minus 1 minus 0 will be minus 1, 1 minus 0 will be 1, still end up the same direction. Put origin here, it doesn't matter, put the origin here, direction always will end up the same way. Direction. So that's why we said that the location of origin is relevant. Sorry, it's relative. It's relative. Anywhere that you put the origin, doesn't matter. Try the 8 corners, you will still end up the same directions. Now for practice, something, sir, how we can practice? Change the origin here, put the origin here, find those 4 coordinates, and then find the direction. You have to end up exactly those direction. 0, 1, 0, 0, minus 1, 1 for B. Now this is finding the directions, the HKL, the indices for a direction. Doesn't matter, any direction that you want to draw. Let's go for another example. Let's say that I'm going for somewhere here. Let's say we have some different, let's say this time we're gonna go some, let's start with this point here. I come to here. Now let's say we have this direction. Can we put the origin at the mid here? Now this is a problem, yes? We can put it here, but we don't prefer to put it in the middle. This is starting from the middle, we come to this corner. Now where do we put the origin? We put the origin somewhere that will be easy for us to do the calculation. Let's decide this will be the origin for me. This is the x-axis, positive x-axis, remember. This is the positive y-axis, and this is the positive z-axis. What do you have to find? You have to find the location or the coordinate of this point, the coordinate of this point, which is the head and the tail. Then we can find the HKL for these indices. Now, well, for point 1, since it's directly on the z, you know that if a point is directly on the z, x and y will be 0. X and y will be 0. So 0, 0, and for the z is in the middle, half. By the way, if it is not clear, it will be given to you on the drawings. It's in the middle exactly, or maybe somewhere it's here 1/4, or sometimes we'll say 2/3. It will be given to you. But if it's in the middle, it's clear, 1/2. Now for point 2, the direction of point 2, of the coordinate of point 2 will be what? 1 in the x, minus 2 in the y, 0 in z. So 1 minus 2 and 0 in the x. Now I brought this one here. The HKL, I didn't say it in the beginning, HKL, there must be integer numbers. HKL must be integer numbers. So if you have fraction, you have to get rid of the fraction. Why? Because HKL, the indices for direction, must be integer numbers. Not supposed to be, for example, if you have 1/2 within them, you have to get rid of it, as you will see it from this example. Now, this is the head, this is the tail. Let's find the HKL. H will be 1 minus 0 became 1. 1 minus 0 became 1. minus 2 minus 0, it is minus 2. Then we have 0 minus 1 over 2, it's going to be minus 1 over 2. Now, this is what we're talking about. You cannot leave it like this. Why? Because you have a fraction. 1 over 2 is a fraction. You have to get rid of this fraction. This is not allowed. This is not allowed. I mean, the fraction is not allowed here. 1 over 2 is not allowed. So what we have to do, we multiply it by 2 to get rid of the fraction. So what will happen in the direction? The direction finally will become an integer numbers. 2 times 1 will be 2. 2 times minus 2 will be minus 4. Then 2 times 1 over 2 will be minus 1. And this is the direction. So write this one down. HKL cannot be integer, cannot be fraction. There can only be integer numbers. Remember, for point it's okay. For point it's okay. Look, point coordinates it's okay. 0, 0, 1 over 2. Point coordinate doesn't matter. But for direction, it must be integer. So we're writing the direction for this. We write it 2 minus 4 and minus 1. Now imagine if this is a BCC crystal structure, you have to find this direction, you have to find this length. So this is what I told you. If you know, if you understood the videos before, lectures before about the distance, the relation between A and R. So if someone asks you to find this distance, you'll be able to find it. Why? Because you know exactly from where to where, and you have those distances, you'll be able to find it. Now you can do any other things. So any other example for direction, all of them will be similar. Just remember, at the end, they must be integers. They must be integers. Now this is what you had the direction. You found HKL. You found HKL. Now the second way of dealing with direction, you may have the directions HKL and someone is asking you to draw. Let's say we're going to give some direction. We have a direction, let's say 1, 0, 1. It's a direction, we have it here. Or a direction, we have it 0, 1, 1. Let's do small ones. Let's do small ones, then we're going to do that when there's 2, 3 inside it. Now you have the direction, you have the HKL, the indices, but you have to draw the line. You have to draw the line. So where is this 101? 101. Now in order to draw these directions, we'll assume an origin. So this is X, this is Y, this is Z. X, Y, Z. Now in order to draw 1, 0, 0, we will put the tail here. We'll put the tail at this point here. Then this will be the head coordinate. Remember please this one. We will draw them, all of them they start with origin, all of them they will start with origin. So all of the tails will be at origin, all of the tails will be, because we're just going to have one origin is enough. One origin is enough. Assume that all of the tails, so writing it, assume all the tails are at origin. Right, for 1, assume the tail is at origin. So we assume that the tail is at origin, then this will be the coordinate of the head. So find this coordinate. Look, this is HKL, yes, HKL. But because we assuming that the tail is at origin, then this will be the coordinate of the head, as we showed to you when you were finding the direction. Now, where is the 101? If I want to find the location of 101, 1 in x, 0 in y, 1 in z, this is the head. This is 1, 0, 1. 1 in x, 0 in y, 1 in z. So 1 in x, 0 in y, 1 in z. Then we're going to connect the tail to the head. Where is the tail? Tail at the origin, and the head is going to be the coordinate that we find. Now this is the first one. I said this is A. This is direction A. If I go for direction B, let's say this is direction B. Again, we assume the tail is at origin. We're going to find this coordinate 0, 1, 1, 0 in x, 1 in y here, then 1 in z will be, this is the coordinate, which is 0, 1, 1, 0, 1, 1. Then we're going to connect the origin to the location that we find it, and this is going to be direction B. Now, let's go for something else. Let's say I'm having it somewhere here. Let's assume that this is the, well, let's give one the, let's say I'm having something here, direction which will be, so you're placing it as 1, -1, and -2. We have a direction like this, 1, -1, -2. Now it depends on you where to assume the origin, because I have minus in the y, minus in the z. So I'm trying to assume in the way that somewhere this corner will be good for me for the origin. This will be the x, this will be the y, and the z will be somewhere here. This will be the z. So I'm assuming this is the coordinate. We have it here, x, y, z. I'm gonna, because I have minus in y, minus in z. Now this is the origin. Again, we assume that the tail is at origin. The tail is at origin. So we need this coordinate. 1 in x, this is 1 in x, -1 in y, -1 in y. Look, I'm coming here, -2 in z, -2 in z. This is the coordinate that we have it. The coordinate 1, -1, -2. Please, if you don't know how to find this one, practice the point coordinate, the video before, then you'll be able to understand how do you find this location. 1 in x, starting from origin, 1 in x, then -1 in y, because this is y positive, it will be negative y in this direction, so from here till here it's -1, then -2, we're coming down, -2, because 2 unit cell we're coming down. This is the 1, -1, -2, the coordinate. Then we're going to link those two with a line from here till here. This is going to be the direction that we have it. We call direction C. This is direction C, we have it. So you start with this origin, it came to this point here. Any other combination that you do, still the same manner. The basic of drawing this direction, you have to first decide the location of origin. Now, deciding the location of origin, as I said, that it needs some practice. So you may decide somewhere, then you will realize that you have to draw the cubes. You'll get used to it, but you have to practice more. So I need in the exam to be, when you're drawing it, I need it to be seen exactly the location of it on the cubes. I need the locations on the cubes. Now what does it mean? If I do the same thing, 1 minus 1 2 minus 2. Let's see, I'm doing it again, but this time I'm going to, now if you have 1 minus 1 minus 2, this is the direction we have it. And if I decide, let's say I decide the origin to be somewhere here, let's decide the origin somewhere here. This is the y-axis, this is the x-axis, and this is the z-axis. Let's say I decided this is going to be the coordinate, the origin we have it. Now we're going to go 1 in x, because we're deciding the tail will be the origin, so we're going to find this coordinate. Now this coordinate 1 in x, this is 1 in x. Now minus 1 in y, I'm not coming like this, I'll go in this manner. This is minus 1, and then minus 2. Well, this is minus 1. Look, I have to go down, yes, somewhere here. This is minus, and then this coordinate here became 1 minus 1 2. Well, it means that you have to draw 2 cubes here for me like this in order for me to understand that where is the location exactly of this. So you have to do it in this manner. So we need to draw some other cubes. The cubes will be somewhere here. There's another line here for that cube. This will be the cube basically, and there's 1 cube here, and the 1 cube down here as well. So you have to draw both cubes for me in order to understand exactly the location of it. Look, just because I didn't know where to select this origin, now I have to draw 2 more cubes to represent the location of that point. Then we're gonna draw the direction. We're going to draw the direction. So those are for nothing. Yes, look, I didn't use them. So you will be the one who drawing the cubes, but first find the location, then you can draw the cubes accordingly. And this is, I need to see it in this manner. Like in the first one, because I decided to be here nicely, I could use this drawing to locate the location of it. But if you don't know where to put the origin, in that case you have to draw new cubes, at least to show me where is the point you put it. So remember, homeworks, whatever I'm giving exam, I need to see the cubes. I need to see the cubes and the location of the point. Where is it exactly? So we need to see this one for checking. So practice to find the best location for the origin. It doesn't matter where you're putting it. It just helps you to save time. If you know, if you use the drawings. I'm gonna share those cubes with the students. I'm gonna share those cubes. Some they can create more than this one by themselves. It's up to them. You can use them while practicing to learn where to put the location of origin. Now, if you check the book, there are a lot of examples there showing those directions. So you see, for example, those directions given to you. I mean, how do you find them? It's something. And then second way, what do you have? You have the directions. I mean, you have the direction, you're going to draw it. That will be something else. We're not going to for hexagonal. I'm just going to show you at the end of the end of the chapters. We have a lot of examples that you can practice. There's the problems. And those coming here. Yes, we have point coordinates and crystallographic directions. So in the direction, you will see that those are, you'll be able to do them within a cubic unit cell. For example, you draw these directions, or you have the directions, and you're going to find the indices, the HKL. You're going to find the HKL. Look, there are a lot of directions that you can find their indices. Well, let's just solve one here, one of those examples. Let's say I'm going to choose here C. I'm going to choose C to find its direction. So this is, there is something written 1/3. It means that this distance is 1/3. Here it's something written 2/3, means this distance is 2/3. This is the tail, this is the head. So let's find the make it bigger. So we're going to find the coordinate of the head and tail, then we're going to find the direction. Well, coordinate of this one, coordinate of this point, which is the tail, starting from origin, we will come 1 over 3, then from there we will come till here, then from here we will go up. This will be the location of this point. Remember what we said, that we assume that there is an atom here and we assume that there is an atom here. That's how we going to find the location of those two points. Now, the point coordinate, I'm assuming that you already studied the point coordinate. 1 over 3, 1, 1. So this coordinate here, it's 1 over 3, 1 in y, 1 in z. This is the coordinate of that point, the tail point. For the head point, we directly start from here and we come to this one here. The coordinate of this point, that's it, we reach to the head, will be 2 over 3 in x, 0 in y, 0 in z. This is the coordinate of the, this is 3, 2 over 3, 0, 0. It seems to be like it's 3, so 2 over 3, 0, 0. Now we said head minus tail, yes, 2 over 3 minus 1 over 3, so 2 over 3. If you go for h, we said h, 2 over 3 minus 1 over 3, it became 1 over 3, yes. Then 0 minus 1, that's going to be for k. 0 minus 1, if you write it down, 0 minus 1 will be minus 1. Then if you go for 0 minus 1 again for L, again 0 minus 1 will be minus 1. Now we said what? We cannot have fraction, so we'll multiply this one by 3. Multiply this one by 3 in order to get rid of this. So the direction for this C is going to be 3 times 1 over 3 will be 1. 3 times minus 1 will be minus 3. And 3 times minus 1 minus 3. This is the direction of this, the indices of this direction, H, K, L for this direction. Any of the others, you'll be able to find them, but you have to practice. Remember, the key point to find directions, indices, H, K, L, is to know the point coordinates. How to find the coordinates. So make sure you practice with the point coordinates in order to be able to find those coordinates easily. And then those coordinates will help you to find the indices. We said the head, the coordinate of the head minus the coordinate of the tail is going to give us HKL, the indices for this direction. The rest you can find them as practice for yourself. Thanks for watching.